my PU2 aspirants. So yes, tomorrow we have final PU2 chemistry board exams, and now we will revise quickly physical chemistry, all the formulas, all the graphs, all the diagrams that we have in this particular exam. Okay, so I'll be just quickly telling you, you just mark it in your book or note down or take a screenshot, and before going to the exam, please revise these diagrams, graphs and formulas. Okay, so let us start with the first chapter, that is solutions. So here we have I'll say concentration terms, formulas are there, but yes, directly this is not asked in the exam, except for molarity, molality and mole fraction. So you can see mass percentage, mass of the solute by mass of the solution, mass of the component by mass of the solution into 100, volume percentage, volume of the component by total volume into 100. Then you have mass by volume, mass of the component by total volume of the solution into 100. Okay, and remember here the total volume should be in ml. All of these where we have taken, right, these volumes are in ml. Next, parts per million, number of parts of the component divided by the total number of parts, total number of components into 10 to the power of 6. Okay. Next, mole fraction, number of moles of the component divided by the total number of components. Mole fraction we use mostly in many numericals. So it is represent XA. Suppose you want to find the mole fraction of A, then it is NA by NA plus NB. Okay, and XB will be equal to what? 1 minus XA. Okay, next, molarity, number of moles of solute by volume of the solution in ml into 1000, W2 by M2 into 1000 by volume of the solution in ml. Okay, next, molality, number of moles of the solute by mass of the solvent in gram into 1000. So number of moles of the solute, you can write W2 by M2 into 1000 by mass of the solvent in gram. Now mass of the solvent is represented as W1. So 2 is always for solute, okay, and 1 is for solvent. Similarly, you can use letter B for solute and letter A for solvent. Okay, so with this we will go to the next part, that is Henry's law. So P of the gas is equal to KH into mole fraction of the gas. Okay, and here what we have, this is your Henry's law. You can see it is a straight line equation. So if you have pressure on the y-axis and mole fraction on the x-axis, you have a graph, straight line graph, where KH is the slope. Okay, next, coming to Raoult's law, P total is equal to P naught A XA plus P naught B XB. So you can see here, this is your Raoult's law for ideal solution. The graph is like this. For non-ideal solutions, you have mole fraction, positive deviation graph and negative deviation graph. So positive deviation, the vapor pressure will be higher, negative deviation, the vapor pressure will be lower. Then we have this one, that is your mole fraction in the vapor phase. So once the vapor has been created, okay, there will be A and B in the vapor form also. So what is the mole fraction of A in the vapor phase, mole fraction of B in the vapor phase? So there we have PA, that is PA is equal to partial pressure of A, P total YA. So YA is mole fraction of A in vapor phase. Okay, and YB is equal to mole fraction of B in vapor phase. Okay. Next, relative lowering of vapor pressure, delta B by P naught. So here it is, delta P by P naught is equal to XB. XB is the mole fraction, so that is NB by NA plus NB. Okay, so you can write down. So if the solution is very dilute, okay, in case of dilute solution, you can use XB is equal to NB by NA. This NB can be neglected in certain cases. Next, elevation in boiling point, delta TB is equal to KB into M. Here if it is a electrolyte solute, then delta TB will be equal to I into KB into M, and KB will also be equal to molar mass into R into TB square divided by 1000 into delta H vaporization. This formula is also there. Kb is equal to molality W2 by M2 into 1000 by W1, where 2 represents, W2 is the mass of the solute, M2 is the molar mass of the solute, and W1 is the mass of the solvent. Here you can see the graph for the boiling point elevation. Okay. Next, depression in freezing point, similar formula, delta Tf is equal to Kf into m. Kf is equal to molality formula, W2 by M2 into 1000 by W1. And here also we can write delta Tf will be equal to I into Kf into m. Okay. And here also you can write Kf is equal to molar mass into R into Tf square divided by 1000 into delta H fusion. Okay. And here we have the freezing point depression. You can see Tf and T naught F. You can show this in the graph. Then osmotic pressure, pi is equal to CRT. C is your molarity. So W2 by M2 into volume of the solution into 1000 into R into T. So here what should be the R value? 0.083 liter atm mole inverse Kelvin inverse, and T is your temperature, should be in Kelvin. And reverse osmosis, if desalination anything is asked, so this graph or this diagram you can practice. Okay. Next, we will move to Van 't Hoff factor. So for Van 't Hoff factor, dissociation alpha value I minus 1 divided by n minus 1, and for association the I value alpha value is I minus 1 divided by 1 by n minus 1. Now here Ka, if I want to find out, that is C alpha square. Okay. Ka formula is C alpha square. Okay. Next, I value, you have this many formulas, but generally we have to use this formula, that is number of particles after dissociation by number of particles before dissociation. Okay, that is your I value. Clear? Okay. Next, electrochemistry, Nernst equation, E of the cell is equal to E naught of the cell minus 0.059 n divided by log divided by n into log of Ni. So I am giving you this one for this particular salt. If I have yes, so Ni plus 2 Ag plus gives Ni2 plus 2 Ag, right? So you can see here that this one, the coefficient should be taken as power for the ions. Okay, so that is what, and n is what? N is the number of electrons that is involved. E of the cell is your E naught of the cell, and E naught of the cell, how do we calculate? That is your E naught of cathode minus E naught of anode. How will you know cathode? Which is your cathode? Cathode is the one where the reduction potential is higher. Okay, or cathode is the one where reduction takes place. Okay, and cathode will always be written on the right hand side. Okay. Next, coming to equilibrium constant. So when the cell is at equilibrium, E of the cell is 0. So we get E naught of the cell is equal to 0.059 by n log K, where K is your equilibrium constant. Okay. So most of the time you may be asked a question to find the value of K. Okay. Next formula, delta G is equal to minus NF E naught of the cell, delta G is equal to minus 2.303 RT log K. Again here what is the value of R? Here it is 8.314 joule per mole Kelvin inverse. Take a second. Yes. Okay, clear? Next we have Faraday's first law and second law. So M is equal to Z into I into T. Z is your molar mass divided by N into 96500. Again N is the number of electrons that is used. Like for example, suppose yes, and here I is your current and T is your time, and remember time here should always be in seconds. Okay. Next, Faraday's second law, M1 by M2 is equal to E1 by E2, where E1 is your equivalent weight and that is equal to molar mass by N factor. Molar mass divided by N. Okay, and again here N is the number of electrons that you should be taking. Okay. Next here these are the different terms and their I can say their symbols and units. So resistance is denoted by R, units is ohm. Resistivity rho denoted by ohm centimeter. then conductance is G, that is your ohm inverse, conductivity is ohm inverse, meter inverse, and then cell constant is your meter inverse, molar conductance is S centimeter square mole inverse. Okay. Then we have here formulas, so you can just quickly revise all these formulas, very important one. Okay. So first R is equal to rho into L by A, that is your resistivity. Conductivity is R into rho L by A, or you can also write, okay, this is resistance, the conductance is G, that is 1 by R, just the opposite of this one, or you can also write down this one as 1 by R, right. So A by rho into L. Okay. Next, conductivity, resistivity R into A by L, so conductivity will be the reverse of this one, so that is, you can write down conductivity is equal to 1 by rho, or you can see L by A into R. Cell constant is L by A, and molar conductivity is kappa into 1000 by C. So here if you use this formula, molar conductivity is S centimeter square mole inverse. Okay. Now here I want to tell you, if the kappa value, see, if the kappa value is in S meter inverse, then lambda value will be kappa by C into 1000. Okay. If your kappa value is in S centimeter inverse, then lambda m value will be kappa into 1000 by C. Okay. Clear? Next, Kohlrausch law, that is lambda naught m is equal to A. So I will use a very simple formula. So suppose MgCl2 is there, okay, and you want to calculate lambda naught of MgCl2, so that will be equal to lambda naught of Mg2 plus 2 times lambda naught of Cl minus. Okay. Next, to calculate alpha value, how do we use this limiting molar conductivity, that is molar conductivity by limiting molar conductivity. Okay. Once you get this alpha, then Ka is equal to C alpha square, 1 minus alpha you can ignore, just you can do C alpha square, or if you just substitute this one you will get this one, but no need to remember this formula, you can directly use alpha, find out here and substitute here and then calculate, that is the best way. Okay. Next, diagrams that you should be focusing from this chapter is your this graph for molar conductivity, dilution with your effect of dilution on molar conductivity for strong electrolyte and for weak electrolyte. This is a very important diagram. Then you should be also remembering the hydrogen oxygen fuel cell diagram and standard hydrogen electrode diagram. Okay, so please practice these 3 diagrams. Next, coming to chemical kinetics. So for zeroth order reaction, what all formulas we have? Rate is equal to K. Then you have integrated rate law, Kt is equal to A naught minus A, where A naught is your initial concentration, A is the final concentration, and T is the time. Unit of K is mole liter inverse second inverse. Okay. And here this one slope, you can just write down, think like this. This is, I can write this equation like this, that I will put it as, if I write A is equal to A is equal to A naught minus K into T. So my suggestion here is, do not use the letter A. Okay, so it is not advisable. Okay, I have used here, but you do not use, you just always write in the form of R. Okay, so I can write R is equal to R naught minus K into T. So this is Y, this is M, this is X, and this is C, right? So you can see here R naught value is the one where this part is having, right? This is the cutting the X axis. Then you have time here, concentration here, so slope is minus K here. Okay. Next, for first order, you have the same equation. So I want you not to use this letter, please use R naught by R. Okay, that is strictly given in the exam guidelines. Please use R naught by R. So if you draw a graph for this one, ln R, so how do I get this? See, I am having equation, one second, you will get a equation here, K is equal to no, one second, what is the equation, I forgot. Okay, so I have this equation, right? Kt is equal to ln R naught by R, right? So I can write this equation as KT equal to ln of R naught minus R minus ln R, sorry. Then I'll take ln R on one side, then I will get ln R naught minus K into T. Now what happens here, see, this is a straight line equation, so I can write this as y, this is y, okay, this is your M, this is X, and then this is C. So if I draw a graph for ln R and T, so what will happen here, I will get minus K, this is the slope, and this point where it is intersecting, that is your ln R naught, okay. Now if I convert it into log term, then what I will get, K2 by 2.303 is equal to log of R naught by R, right. So now if this is my y, this is M, and this is X, then there is no slope here, sorry, there is no y intercept here, so I can draw a graph like this, log of R0 by R, okay, versus T here. So the slope is K by 2.303 passing through the origin and a straight line, okay. So these are the two equations that you will find, okay, you can see here. Okay, next half-life equation, T half is proportional to 1 by A naught to the power of n minus 1. For zeroth order it is, sorry, for zeroth order it is A naught by 2K, and for first order it is 0.693 by K. So if I have a graph for T half and A naught, okay, for zeroth order, then you see what is the graph T half and A naught, it is a straight line equation passing through the origin with slope 1 by 2K, okay. And for the same graph if I do, that is T half and A naught, but for first order, okay. So it is independent of the concentration, so it will remain like this, that whatever you change the concentration, the half-life remains constant, okay. Next, Arrhenius theory. See, Arrhenius theory says that reactants gets converted to products through an activated complex, means first reactants are converted to an activated complex and then they are converted to the products. So that is why this is the graph for Arrhenius theory, okay. Next, if the question is asked from Arrhenius equation, okay, this is the Arrhenius equation. So sorry, if this is the Arrhenius equation, if I take here ln K is equal to ln A minus EA by RT, okay, then if I take it log here, log K, okay, is equal to log A minus EA by 2.303 R into 1 by T. So if I draw a graph, this is Y, this is M, this is X, and this is C, right. So you have EA by 2.303 R negative slope here, okay, this is ln K and this is 1 by 2, you can draw from here also, this is the graph. Now when it is done for two temperatures, we get a modified formula like this, log of K2 by K1, okay. So by using this graph we can find the activation energy of any reaction is equal to EA by 2.303 R into 1 by T2 minus 1 by T1, okay, sorry, not like this, just a minute, T2 minus T1 divided by T1 into T2, okay, that is what you can substitute here. Next, effect of temperature, you have to do Boltzmann curve and you have to show that when the temperature increases, the number of particles having energy greater than the activation energy increases, and that is why the rate of the reaction increases. And here you can see the what else, activation energy, the catalyst, role of catalyst. So when I use catalyst, the activation energy decreases and that is why the rate of the reaction increases, okay. These are the diagrams. And yes, that's all students, these are the overall all the formulas and diagrams that you should be preparing, and please go through them, revise them, draw them once, write down all the levelings and practice them, okay. All the very best students, and I hope your exam goes really well tomorrow, and if you have any doubt please comment down, I'll definitely address to it. Thank you.